Welcome to Truly Terrified, Paranormal versus Physics, where we talk about some really weird stuff, and Joe the scientist explains how it's not possible, or maybe it is. I'm Lynn, and
I'm Joe.
Today, Joe's going to talk about something he's mentioned several times on different episodes called Quantum Immortality. I have no idea what this is. I haven't looked it up, so he's going to do his best to terrify me. Would you please keep it simple for me?
Yeah,
also?
I'll try.
Okay, what is quantum immortality?
Okay, so quantum immortality comes from the many worlds interpretation of quantum mechanics. Going back a little bit, I've described this before, but this is generally how it's described. You take like a little electron producer device, produces electrons. You just put a little bit of current into it, so it just produces an electron every once in a while. And in front of that, you put a plate, 2 small holes drilled into it. And then on the other side of the plate, you put individual detectors. So each one will like light up when one of the electrons hits it.
Okay.
So there's definitely lights. Each individual light can only light up when an electron hits an individual detector.
And it has to go through a hole.
And it has to go through one of the 2 holes.
Okay.
So it's pretty obvious.
And this is all at a super microscopic scale.
Yeah, tiny level. Although you can do it with light at a macroscopic level. It's the same principle. In fact, I think I even did that in school, and it looks pretty cool. In fact, I think maybe you can actually see it occasionally when light diffracts off of your eyelashes, because the like focusing of your eyes past your eyelashes, and then your eyelashes form a grate, so like you can picture multiple lines of eyelashes. Light is going through the lines. Anyway, so your intuition says you heat up the electron generator, shoots off electrons. They go through one of the 2 holes. They go through on a straight line to one of the detectors, or rough circle of detectors. The detectors will light up, so you'll see like them light up
as the electrons are going through.
As they go through, and it will just be like a shadow or a light beam cast through the holes to those detectors. But that's not what happens. If you watch the electrons, like you devise a way to minimally influence them, but watch them as they go along, that's exactly what they'll do. They'll go through the holes, they'll go to the detectors, they'll light up the detectors exactly like you imagine it.
Because you're watching.
But it's because you're watching. If you don't watch on each one of the detectors, you just record like what they did and put it all into a box. So you are recording, you're not looking at the detectors, you're not looking at the electrons, whatever. You'd expect them to still behave the same way, but they don't. Instead, what they do is they act like a water wave, like coming out of the generator, kind of expanding out, going through both holes, kind of interacting with themselves, and then kind of spreading out from there. Like ripples. So the main thing, though, is they go through both holes, interact as if they had both gone through both holes, and then kind of ripple out. So that's what people imagine is going on. They're not looking at what's going on.
Because by looking at it, you alter the results.
So after they look at the recording, though, they see this wave-like pattern on the detectors. So the detectors will detect things as if a wave had gone through. So they're inferring that the electron is acting like a wave, and it's going through acting like a wave and self-interacting, but no one obviously knows what it's doing because they can't look at it, or else it will.
Now, why would looking at it change the outcome?
Yeah, that's a really good question and an excellent segue into the next point, which is the fundamental problem is, how can a particle go through 2 of the holes, interact, and then arrive at one of the detectors? Because if there is this thing that's spreading out, how does it immediately, when it should arrive at a detector, arrive at only one detector? That's really strange. And what would it look like if it arrived at multiple detectors? So the technical word for the wave, multiple possible points it could appear at, called a superposition, which literally just means multiple particles superimposed over one another, but they're interacting. That's how it's formulated mathematically. to predict where the particle ends up, but no one knows what it really is. One of the interpretations of what's actually going on in quantum mechanics, literally that problem, one of the interpretations is called the many worlds interpretation. The many worlds interpretation essentially says the superposition, it never turns into one of that particle hitting one detector. It still goes through and acts like a wave, but we only see it go through and hit one detector because we also are acting like a wave. But we only can see ourselves as acting as if we detected ourselves, a single thing instead of a wave. So quantum immortality comes from the people who thought up the many worlds interpretation, I believe. Quantum immortality is essentially saying a person has to observe one of the outcomes in order for that superposition to resolve into a single point. So like you don't have to observe like the data of which thing the particle hit, but if you do observe it, you will observe one of the detectors. So, like if you had 100 detectors, you might see it arrive at, like the one that lit up was the left 20th detector or whatever. If there were outcomes that are possible, but you just couldn't observe for whatever reason, you just, like those ones you can't observe, then the probability you'll observe those particular ones are 0. The probability that you'll observe the other ones is slightly higher. So what that essentially means is, like, if for whatever reason there was one detector way on the far end that it was just like God came down and said, no, you can, like the particle can arrive here, but you can't see this one. You won't ever see it arrive at this one. Then you won't see it arrive at that one. You'll see it arrive at a different one. Like you can think of it like if you could only see it arrive at the left 5th detector, then you'll see it arrive at the left 5th detector. The other ones,
even though if you left the room, you could come back and see that it arrived at perhaps all of the detectors.
Yeah, so like in the case that you record which detectors the thing arrived at, left the room, came back, and you looked at the pattern, if some of them were impossible, then the other ones will have been filled up. This concept becomes more obvious when you think about, okay, what if you die? In all of the interpretations of quantum mechanics, there's something called the wave function collapse, which is it's just saying that the superposition of the particle, so all of the different possible outcomes are superimposed, and the wave function collapse is it resolves itself to a single possibility.
Okay.
And all of the interpretations essentially in some way say you have to observe it happening. And some of the interpretations are very explicit that it's observation by a conscious observer.
Not a machine.
I'm paraphrasing, and there's a lot more intricacies, but that it takes an observer, quote unquote, to look at the outcome, and then it wave function collapse, and it resolves itself to a single outcome.
So every time, though, somebody observes it, that is what happens.
Yeah. There's different interpretations of what's going on. Many worlds interpretation says, every outcome does happen, but what are essentially different universes? You can't interact with those ones because you're a wave and you just can't do it. You can see a definite outcome in your universe, but there's a lot of different interpretations that explain it differently. Since it takes an observer to collapse it, what happens if you stop observing? Like fundamentally stop observing? Then no outcome can be realized, meaning none of the detectors would detect a particle. The universe would not evolve at all. Obviously, it would for other individuals. From your perspective, we're talking about the many worlds perspective or interpretation. So, like you are on your own track of universes, you're carving through the larger universe, and what you're observing is defining where you're going, essentially. Like there's this bigger universe of all the different possible outcomes, and you're seeing only one little line of it. The outcomes...
and everybody else is seeing their own little line of it.
Yeah. Well, sort of. It kind of gets hard to conceive of at some point, but every person, so this is kind of how it goes. Every person is observing their own line. At each instant in time, almost every version of themselves has branched off into a different line.
Every version of themselves.
for instance, us talking right now, the person I'm talking to from my perspective is a real person, a conscious observer. These are really extremely difficult topics. If you have to observe a possible outcome of the superposition as it evolves in order to determine what happens, if you can't observe or you don't observe, then there are primarily philosophical problems of what could happen. So if you look at the outcomes of the experiment, so you're looking at which detector the electron arrives at. If you just walk away, the electron in the many worlds interpretation goes through all different possible detectors, and maybe in one of them one of the different possible outcomes, version of you comes back, sees which detector it went through, and then you go and live your life. But if you never look, it will never have resolved in your universe. Just take it for granted there are many universes. It's literally the many worlds interpretation, saying there's many universes. And they essentially are analogous to the electron as it's flying towards the detectors. Those are just your universes. They're interacting, but you are the detector. So you are constantly observing where you are in this possible line of detectors. So you can imagine you are like the electron having arrived at the detector. You are the detector lit up. So there's a load of different possible outcomes, and they're all real. But you're looking at the one that lit up, which is always the one you're on. And as time goes on, there's new detectors further ahead, and you'll see only one of those, and of an array of possible different detectors. And that's just how it goes, out and out and out. You'll always see your own detector lit up. It's just like, oh no, there's one detector, and it's just always lit up. But there's a whole array of infinite number of detectors that are always branching out, and like you can imagine the electron going through one detector, that one lights up, and now there's a new array of detectors just for that one. Where does it go next? So, if you can imagine, what happens if at some point the detector switches off or something, So quantum immortality is the idea that because you have to observe an outcome, you always will observe an outcome. You have to. So for instance, imagine you are walking down the street and a bus comes. Now, from a many worlds perspective, the possible ways you could walk out in the street and get hit by the bus and lights out, you won't observe those universes because how could you? You're dead. But the ones where someone pulls you back, doesn't let you walk in front of the bus, those are the only ones you could observe. So it's saying, and not everyone, I think probably only a very small minority of people believe in quantum immortality, but they say that of all the different possibilities, you won't observe the ones where you are taken out of commission. You won't observe the ones where you die. So, however unlikely it is, there will always be an instant. The next instant will always be one where you are still conscious, whatever that means. And there are some people who believe differently, it's essentially like your consciousness will survive, but it might be vastly different or whatever. So interestingly, the one way you might quote unquote prove quantum immortality through a quantum suicide experiment.
What?
So quantum suicide is the counterpoint to quantum immortality. You just do something where it's 100% guaranteed you're going to be killed or stop observing. Like, for instance, you put yourself in Schrodinger's box, you take a small capsule of cyanide gas or whatever, hook it up to a radiation detector that's detecting radiation from a decaying atom or something. And then when it does, then it will kill you. But if you're the one who's quantum immortal, it will never kill you. So you can then tell everyone, look, I just proved it. Now they try it and they die, of course, because it has this weird property that you're the only one who can observe yourself being quantum immortal. So if you can imagine the line of detectors, electron goes through, you are the detector that's constantly lit up. There are other detectors that you can observe, but at any point, from your perspective, their electron went through and is probably not going to end up now at the analogous detector that you would see them on. So like if you picture like a person going through a doorway and acting like a wave function, most of them are like walking this way and that way, but you only see one. Most of the outcomes you don't see. And it's hard to say like, what does most mean from a mathematical perspective or whatever? But you won't see most outcomes. So that's what I mean, like a person, if you're talking to a person at every instance of time, the electron goes through their detector, and then it goes off right field, and the one you would see is super unlikely. You're still seeing a version of them, but it's just one version. Almost all of the other versions are in different, you can't observe that anymore. So anyway, it's a very hard concept to understand, but it does bring up some interesting points. So like if you suppose quantum immortality is real, then why were you ever born? Because that, looking back, you weren't observing then. The detector wasn't made in the factory yet. So how is it lit up? One of the things that's related to this that I kind of wanted to talk about was there can be situations. Nothing stops these certain situations where there's in physicalist universe. That means there's laws of physics, and like our brains, our minds are because of like neurons firing and all that. So assuming all that, there can be, and there probably necessarily are physical processes. That means stuff going on, like particles hitting each other, or like animals interacting or whatever. That the information that they're encoding. So like for instance, you can picture ants like marching in a line, and the order of the ants, that's the information they encode, is also evolving in time. These certain physical processes, again, like ants marching in a line, the order, as the system evolves, as the process evolves, the information will also change. So there can be situations where the information the process encodes has its own rules that supervene on the physics of your universe. So that means in order for those rules to change, the physics of the universe would have to change, or the physical process would have to change, or whatever. Like for instance, you can imagine throwing a ball or something. The physics of the ball in your mind aren't actually the exact physics of how the ball would go.
Right.
Even if you can imagine it perfectly, there's small deviations, whatever. So this is an example of what I was just talking about. You have in your mind information that's encoding something, who cares? And it has its own rules of how it evolves. But those are dependent on the physics of like your body and whatever. So you can imagine like the ball being thrown, whatever. You are essentially making your own universe when you imagine things going on. If in your physicalist universe, so like, everything, the real universe, there's a physical process that is encoding information that really looks like its own universe from inside, then it essentially is its own universe. So you can imagine a person who goes into a coma or something, and they're having this whole imagined universe. And some people say, oh, well, there's nothing stopping this universe from what you perceive as being like a dream or something, which is kind of a disturbing variant of how the universe actually is. Essentially, there's a lot of different sub-interpretations of quantum mechanics. One of the interpretations that goes along with many worlds interpretation is many minds interpretation. Many minds is essentially, there aren't really other worlds, it's just your perspective is branching off. So like the detectors, the electron goes, and your detector is always lit up, but it's just the perspective that one is lit up. Instead of there actually being different universes, you have encoded in your brain a perspective of the universe. You have information about the universe that you've collected through your eyes, whatever. The light you collected through your eyes is from objects that you have also encoded in your brain. So you have in your brain a version of the universe that the stuff like you, not what you imagine, but like what you actually think you perceived. The information you're encoded in your brain is not reality. It's, again, that same process I was describing before. Physical process can encode information that has its own physics and that is dependent on the larger universe. That larger universe is kind of simulating that smaller universe, but it's the information that's evolving, not actual things. So like you imagine the ants marching along, the order of them might change based on some weird pattern. And maybe the order of the ants is actually simulating another conscious thing that's...
Oh, that's a thought.
Yeah, so that's essentially what's happening from, as far as like the best interpretation I can see with quantum mechanics, that's what's going on.
Everywhere at all times.
With your perspective.
Okay.
So the information in your brain is classical information, which means it looks like this universe, not like the crazy one, the crazy wave universe. Because you can only encode classical information, that means information that looks like it's from this one, even if it's from a strange source, it will look like, no matter what you ends up being in your brain, it will always look like it's from this universe. Regardless what the universe is actually like, information in your brain is wrong. Or I mean, it's not the full story. From quantum mechanical perspective, you can't see the other universe that branched off. So you can't see the universe where the other detector lit up. That means you can't see the real information about the universe. You can only see a type of information. It's like the ants, that conscious thing they're simulating as they shift around. It doesn't know that it's just ants marching along, Or like you have a kind of a whale creature that's huge and it's evolved a brain that's like 40 times bigger than its body or something. And it's imagining this whole universe with like individual people, and those individual people don't know that they're part of a whale brain, So anyway, consciousness from that perspective in quantum mechanics. So like a many worlds, many minds, information, theoretic interpretation of quantum mechanics. From a philosophical standpoint, consciousness, which is the thing you lose when you die, is the information stored in the larger physical process that defines what even the universe is for you. So it's not just, if you die, you lose information about like what was happening in your classical universe, whatever. You might lose information about what is even a classical universe. And from that perspective, it might be that you shift over to a different version of reality that literally just can't die. For instance, imagine the information in your brain defines which detector you think you're lit up. So when you quote unquote die, it's really just like you're shifting and you're seeing, maybe now you're looking at 2 or 3 different detectors, which combination is lit up. And then from that point on, you're not just one detector, you're 2 or 3 different detectors. In the combination, you only see this same combination. In which case, it becomes much more difficult to even contemplate that one of them will go out and it will just shift to another. So from the information theoretical perspective of quantum mechanics, many worlds interpretation of quantum mechanics, what you think is going on in reality, it's like this. You have a flashlight, you're pointing it out in the dark. That's what you think the universe is. But it very well might be that something completely different happens. So it's like this. Okay, imagine this. Many worlds interpretation U, so there's multiple variants of U splitting off. You can imagine it like you're hiking down a road and the road branches. So every once in a while, there's also a version of you that goes off down a different road. If you quote unquote die, it doesn't necessarily mean that you stop hiking and you just lay down or whatever. It might mean that you are now the version of you, which again is not just you, it's everyone who's hiking on every possible different line, is now from two different perspectives that are communicating this information being passed between them. From this perspective, there's nothing stopping you from like being an amalgam of different universes. From that perspective, the physics of what you're apparently seeing would change. I think I described this before. There's two ways to say if you see a change in the universe, you can always ascribe that to a global change, so like the whole universe changed, or a local change, you changed. So from keeping that in mind, quantum immortality doesn't necessarily mean that you just can't, like how you see yourself now can't die, but rather that a local change also allows you to your perspective to continue. So for instance, maybe that looks like you are on your parent universe, you're thinking, living your life thinking, oh yeah, this is normal reality. And then you quote unquote die. And then you shift over and you're born into this alien reality. And then you grow up and now you're you now, But really what happened was you just kind of shifted in this quantum mechanical space and you're just encoding different information. That's how I would describe quantum immortality with the particular bent of the information theoretical perspective. There is something else important to bring up, though, with quantum immortality.
Okay, so I have kept quiet and I have many, many questions, and I hope in this next episode I can ask those questions and I won't screw Joe up because he's on a roll. The second half of this episode will be up on Saturday. Thanks for coming along for this ride because it's been a crazy one and it's gonna get crazier, I think. Our contact information is in the show notes, and as always, if you have a story you want to tell, send it to us. Please share, subscribe, and leave a review wherever you get your podcasts. Thanks for listening, and never be so terrified you can't run.